Hi guys. If you're watching this, it is because either you were absent or I am absent. Ordinarily, I do this lesson when I am in the classroom, but in this particular case, I cannot be, so I'm going to try to do the best I can. I also have a cold right now, so I have a cough drop in my mouth. I hope that's not too distracting, and I also might be coughing from time to time, and I hope that's not too distracting. I will try my hardest to not. So, in chemistry and in life, sometimes you have unknown substances. And when you take an unknown sample, you can send it to a lab, and the information that they'll spit back out at you is which elements are present and what percentages they are. So there's a way that we can take this information and turn it into a chemical formula, and I'm going to show you how to do that in just a little bit. To do this, we use a poem, and in the spirit of poetry, I'm going to put on this lovely hat over my headset and perform it for you. So here's the poem. Percent to mass, mass to moles, divide by small, multiply till whole. Everybody clap. Let's apply it as I take off my hat. So, assuming, let me back up a little bit. We have an unknown sample. This is the information that came back from the lab. So, I would like to go back to the poem for a bit. Percent to mass, mass to moles, divide by small, multiply till whole. So if you assume that you have 100 grams of the substance, then if 64% of that substance is carbon, then I'm going to try to write with my pen now. Sorry, it's a little crooked. Uh-oh. I lost my connection. This is not going well for me. Okay. Oh, there it is. Now that's messy. So, I'm going to move on and come back and activate my pen again. Sorry. I'm not going to have time to edit this either, so you get to see all this rubbish. Here we go. If you assume that you have 100 grams, then 64.8 grams of this is carbon, and 13.62% is, or 13.32 grams. Oh geez, I'm just on a roll. I'm so sorry. 13.62 grams is hydrogen. 21.58 grams is oxygen. So we just did the first part of the poem, percent to mass. This percent, assuming 100 grams, we have this mass of each substance. Now the next part is to convert to moles. To do this, we're going to use the molar mass conversion. 1 mole of carbon has a mass of 12.01 grams. I'm sorry, this looks like a kindergartner is writing it. 1 mole of hydrogen has a mass of 1.01 grams. And 1 mole of oxygen has a mass of 16.00 grams. When we do the calculations, we will get the number of moles of each substance. So for the first one, looking at my reference sheet, we will get 5.40 moles of carbon. We will get 13.49 moles of hydrogen, and we will get 1.35 moles of oxygen. So the next part of the poem, let me start from the beginning. We had percent to mass, mass to moles, divide by small. This number right here is the smallest. So we're going to divide each of these by 1.35. Divided by 1.35 equals 1. Divided by 1.35, that happens to equal 9.99. And divided by 1.35, that happens to equal 4. So in this substance that is unknown, it has 64.8% carbon, 13.62% hydrogen, and 21.58% oxygen, has a chemical formula of C4. This is very close to 10, H10, and O. C4, H10, O. And this substance happens to be butanol. It's a fuel. So let's apply this to a task that I have for you today. This is the scene. Strange case of Mole Airlines Flight 1023. At 6:02 a.m., you and your team of medical examiners are called to the scene of a plane crash. You find evidence of a pre-crash explosion. At the site of the explosion, a material has been found. Subsequent chemical analysis shows that it contains carbon, hydrogen, nitrogen, and oxygen at these percentages. The mangled passengers are found in and around the crash. They must be identified by the substances found in their belongings or in their bodies, since they are not recognizable, and their dental records are not available. Upon further investigation, one passenger was suspected of having been murdered before the crash. The time of death was approximated at 1 hour prior to the crash. Very peculiar. Let's see if we can use the same method of finding the chemical formula of a substance that we used in the previous thing. Now, when I go back and look at the poem, there was one part that I didn't need to do multiply till whole. And that was because each of the numbers after dividing by small already were equal to whole numbers. In the next case, I'll show you an example where that isn't the case. So, this is the substance and the percentages. So again, and I have the poem hidden here, and I'm going to change this to a black pen. I have the poem included on this slide. Here's the poem: percent to mass, mass to moles, divide by small, multiply till whole. So percent to mass, we have 37.01 grams of carbon, 2.22 grams of hydrogen, 18.5 grams of nitrogen, and 42.27 grams of oxygen. Now, if this is the first time this video has ever been used in a class, I am looking at the whiteboard right now because the same calculations are written out on the whiteboard if you want to use that as a reference because of my sloppiness. So, mass to moles. I'm going to convert each one of these to moles. Multiplying by a conversion factor, 1 mole of carbon has a mass of 12.01 grams. 1 mole of hydrogen has a mass of 1.01 grams. 1 mole of nitrogen has a mass of 14.01 grams. And 1 mole of oxygen has a mass of 16.00 grams. Now, if you haven't, I would like you to write this out and copy it down up until this point. If you haven't been copying it down already, I want you to pause it, write this down, and copy it. And then I would like you to go through the calculations. So, the answer to the first one is 3.082 moles. And the answer to the next one, when I take 2.22 times 1 divided by 1.01, is, I'm looking at the board right now for a reference, 2.20 moles. 18.5 divided by 14.01 is 1.32 moles. 42.27 divided by 16 is 2.642 moles. One thing I want you to notice is that at this state, I kept the same number of significant figures as what was in my original calculation. The next part of the poem, divide by small. The smallest here, we have 3.082, 2.2, 1.32, and 2.642. The smallest is 1.32, so we need to get the ratio. So we're going to divide each by 1.32. Whoops. 1.32 divided by 1.32 divided by 1.32 divided by 1.32, and this one equals 2.33, which is not a whole number, and it's not even close to a whole number. This one equals 1.66, also not a whole number. This one equals 1, that was easy, and this one equals 2.00. Okay, so at this point I do not have whole numbers, so I need to multiply till whole. If your number is about 1/3 or 2/3, you're going to multiply by 3. And the thing is, you have to multiply everything by 3, all of them by 3. If it was 0.5, you would multiply by 2. So here, multiply this by 3, and I get 7. When I multiply this by 3, I get 5. When I multiply this by 3, I get 1. And when I multiply this by 3, I get 6. So the formula of this substance is C7H5 NO. Oh, I made a mistake. You probably caught that. 1 times 3 is supposed to be 3. N3O6. And if we look at the list of possible substances, C7H5N3O6, it happens to be trinitrotoluene, so TNT. So going back to the original scene of the crash, the explosion material is TNT. It has been found. It is on site, and this is the chemical analysis. This is the other information that's given. The passengers on crew, there are 8 of them, and data has been collected. Substances were collected, sent to the lab. Passenger 1 has a substance with 67.31% carbon in his or her blood, 6.99% hydrogen, 4.62% nitrogen, and 21.1% oxygen. Now, you have to use the same method to determine what substance this is that is in the blood of passenger 1. And when you do that, try to figure out who the passenger might be. This is a list of our passengers and crew. Amedeo Oldere has a heart condition. Connie Majors is a pharmacist. Jim LeClaire is a baker. Archie Starr is a teacher addicted to sugar-free drinks. Reno Henderson, a professional athlete. He's just been suspended for drug violations. Lisa Johnson's an environmental engineer who is severely depressed. Norm Anderson, a suspected leader of a terrorist organization. So, one thing that I want to look at here is we found the identity of this first substance, 37.01% carbon, 18.5% nitrogen. Look closely at the passengers and what the contents are. There is a passenger who has that same compound analysis found in his or her pockets. And that passenger is passenger number 5. TNT. The same percentages as what was found on site. So this was found on site. It was also found in the pockets of passenger number 5. There's a clue. Now I want to remind you, the mangled passengers are found in and around the crash. They're unidentifiable. Upon further investigation, one passenger was suspected of having been murdered before the crash. The time of death was approximated at 1 hour. Who was killed and who killed that person? And speculate why. Let's look at the people again. We have Amedeo Oldere, who has a heart condition. Poor guy. His family's probably crushed. Connie Majors is a pharmacist. Jim LeClaire, a baker who was on board this plane that crashed. Archie Starr, a teacher who's addicted to sugar-free drinks. Reno Henderson, a professional athlete just suspended for drug violations. Lisa Johnson, an environmental engineer who's severely depressed. Bill Cadillac Jackson, a suspected drug dealer. Oh, Bill. And Norm Anderson, a suspected leader of a terrorist organization. These are our 8 passengers. On the worksheet that you will be given, which can be found on the top central desk in my classroom, there's a list of the passengers and the most probable identity. Also, the possible compounds that these passengers may have had either in their blood or on their pockets are included. Codeine, cocaine, aspirin, aspartame, vanilla. Sorry. And the list goes on. Okay, so your job is to use the same method that I just used. Percent to mass, mass to moles, divide by small, multiply till whole. An example is on the board. If it's not on the board, it should be in your notebook right now because I did ask you to copy this down. So I want to wish you good luck. I hope that you find the solution to this mystery, who was murdered and who was the murderer, and is the plane crash even affiliated with any of that. So, good luck. What you have to do is you have to, again, use the methods, use the method from the poem for each one of the passengers. If you're sitting at a table or working with someone, I suggest you start with passenger 1 and someone else starts with passenger 8. If the passenger has 2 substances, it's 2 separate calculations that you have to do. And then try to work as a team to figure out what is in each of these passengers in their blood or in their pockets. So good luck. Have fun. And that is that.